Hello everyone and welcome back to our DSS series. In our previous video, we learned about the time complexity and space complexity and why they are important. So in today's video, we will focus on the time complexity in details. We will learn how to measure the time complexity and we will look some common types of the time complexity. Then we will see some examples with the real code implementations. So by the end of these lessons, you will be able to analyze the runtime performance of any algorithm and choose the best one. So let's get started. So what is time complexity? So in the previous video, we have a brief introduction about the time complexity. So it is a way, so time complexity is a way to measure how the execution time of an algorithm increases as the input size and increases. Okay, so think of it like this. If an algorithm takes 1 second for 10 inputs, okay, for 10 inputs, it takes 1 second. How long will it take for 1 million inputs? If it is 1 million, how many seconds will it take? Will it be 10 seconds or 100 seconds or 1 day? So by analyzing the time complexity, we can predict how an algorithm behaves with larger inputs and whether it will be efficient or slow. So most of the time complexity will be measured in the big O notation because we will consider the worst case scenario. Okay, so we will come into that in the later part of the lessons, how to measure in the big O notations and the later lessons. And also it helps in comparing the different algorithm for efficiency. So we have the different algorithms. So we have to compare the different algorithms which take lesser time in the time complexity. Okay, so let's see how to measure the time complexity. So to measure the time complexity, we follow three simple steps. Okay, the first one is count the number of operations. Okay, so an operations can be either addition or multiplication or a comparison. So you should remember that more operations, okay, more operation means more execution time. Remember this one. Okay, more execution time. So second steps, you have to focus on the dominant terms. Say like for example 5n, you should focus on, say for example, ignore constants like say for n, okay, or 10n square. So you have to ignore the constants. Say you can ignore this, you can ignore this 5, okay, you can ignore these constants. Okay, another one is that say if you have a lower order terms like plus 3 or say plus log n, okay, you can you can you can remove these ones. Okay, so I mean you can drop these ones in measuring the time complexity. What I want to tell is that we only care about the fastest growing part of the function. Okay, we should focus on the dominant term only. We should ignore these smallest terms. Okay, next we have to express in a big O. Okay, we use the big O notations to represent the time complexity in a simple and a standard way. Okay, so let's understand with an example. Say for example, check this function. So it is to print, okay, to print the numbers from 1 to n. So we are going to take an input. So the first step, the loop runs. So let's see, so integer n for n I equal to 1 and I is less than 1, I is less than or equal to n, and I is incremented by 1. So first, in the first, the loop runs n times. Okay, we should check how many operations is the function is going to operate. So the loops will be run for n times. This is the first step. Second step, we have to check that which is the dominant term. So in this case, the dominant term is n. Okay, and after finding all these number operations, the dominant term, then we can check, we can tell that the complexity is O of n, that is linear time complexity. Okay, so meaning, what does it mean by that? So as the input grows, okay, as the input grows, the execution time also increases. Okay, execution time also increases linearly. Okay, okay, I will explain in a simpler terms again. So let's analyze some functions. The loop runs n times. Okay, the loop runs n times. So for its value from 1 to n. Second step. What is the second step? Each iteration takes constant time of constant time. It takes constant time. Constant time. That is because O of 1. Okay. Third one, we have to calculate the total time taken. Okay, what is the total time taken? We have to multiply n into O of 1. Then we get O of n. So this function has O of n time complexity, meaning as the input grows, the execution time also increases linearly. So let's see some common times of the time complexity. We have the constant time, we have the logarithmic time, we have the linear time, we have the linear arithmetic time, quadratic time, we have the exponential time. So we will go through some of the most common time complexity with the real examples. So let's start it with the constant time complexity. So in the constant time complexity, see, let's say an algorithm has a O of 1 time complexity. If it runs, runtime doesn't depend on the input size. So you can see integer get so we are iterating an input of array. Okay, array can be, we are taking an array, we don't know the size, so let's say we have a size from 1 2 3 4. Okay, let's say we are here, the function is trying to return, say array of 0 means it will return this number 1. Okay, we are just assessing the element, we doesn't depend on the input size. Say the array size can be many times, but we won't care about the size of the input. We are just only assessing the element in an array. So no matter what the input size is, we execute this function executes in the same time. So thus, say for example, and assessing an element, having 10 million, whether it can have a 10 million also, up to 10 million, this array going to like, say what if it is this the algorithm doesn't depend on the input size, so we will get only the time complexity of O01 because it is going to be constant. Okay, the time complexity, time one increases, even and the n inputs increases, the time will remain same. Time will remain same, that is constant. Okay, so it is not proportional. So let's see another time complexity, that is the logarithmic time complexity. So in the logarithmic time complexity, we have to divide the problem into smaller parts. Okay, so let's see, if you have an input size for n input size, we have to divide the array size into half. So always remember that in the logarithmic time complexity, we have to divide the problems. Take one example, you have to find a phone number in a phone book. Okay, you have to check the phone number, you want to find the phone number. So if you want to find the phone number, like you have to search each and every name from the beginning till the end, but this will take lots of time. But in the logarithmic, you have to divide the into half. Okay, so if the phone number lies on this first half, then you can, then it will take less time. Either if it is on the second half, then it will also take less time. Instead of searching all the way from the beginning till the end, it will take a lot of time. So we have to divide into half. Say for example, I want to find a name, Lenin phone number. Then you have to check where the Lenin lies, L series lies. So if it is L lies on the left side, then you can search only on this left. If it is on the right, we have to check on the right side. So let's take a binary search. And the same rules follow for the binary search. So in the binary search, what we are doing here, we are dividing the area size. We have to divide the area size. Then we have to search on the if the target number is on the left side or the right side. If it is on the left side, then we have to divide again. We have to divide the left side again, and we'll check whether this lies the target lies on this side or this side. Okay, we have to check either on this or this. Again, if it is not, if we still there is still the size is area, if it still can be divided, when we have to divide till we get the target number. So until we get a target number, we have to keep dividing. Okay, only after getting the target we have to return the middle. Okay, that is how you have to find the time complexity. So here the time complexity, we are dividing the into half. You should remember that. Okay, now let's see another time complexity. That is the linear time complexity. So in the linear time complexity, what we are doing here, this linear time complexity, the only thing is that as the input size increases, okay, so as the input size increases, the time also increases. The time also increases. Remember this one. So it executes in a proportion to input size. So scanning a listener. So we want to find a number of, we want to find the in the array. So for example, we want to find an element in the array. So we have to search each and every element. So okay, we have to search each and every element till we get the target value. That is a linear time. So if we have, so for example, we have only 5 elements. For 5 elements, it is fine. But if we have more than 10 millions, it will take more 10 million times. Okay, that is the time complexity. So another, let's see the quadratic time complexity. So in the quadratic time complexity, what we have to do, we have to check the, what we have to do, we will see the some nesting loops. Okay, so it will grow exponentially. Okay, the time going to be increases exponentially, means double the time. Okay, the time complexity will increase double. So here we are, you see two nesting loops, like for loop 1 year and the for loop year. So it is going to be increases 2 times. Okay, how many times the loop will run? So here the loop will run for only 1, here another 1. So here n times. Okay, the first loop will going to run for the size n, and the second one also needs to be going to run for n times. So it is going to be n square. Okay, so this is how the quadratic time complexity going to be measured. So if you find any loops, okay, in the time complexity or in the pro function, then it is going to be n of square. That is quadratic time complexity. Now let's summarize today lessons. So in today's lesson we explain about how to measure the time complexity, right? We measure the time complexity. First step is we have to find the number of operations. Okay, and then we have to second step is to check the or focus on the dominant terms and ignore the non-dominant. And third, we already checked some common types of the time complexity with some code examples. So in the next video, we will discuss about the space complexity and its impact on the program efficiently. So see you there. Thank you.